Hey team, so example B is another one where we are trying to label the acid and base as well as their respective conjugates. So again, look at what's going on. Now, if you see water, water can act like an acid or a base. Water is really special that way. So in this case, we have to focus on the very first compound that we see. It's HBRO. So I see an H in front. My gut tells me it's going to be an acid because I kind of know those Arrhenius definitions, but let's see how it behaves. So if I look for this root, the BRO minus, it does exactly what I think it will. If it behaves like an acid, it loses a hydrogen. And if you see at the end, it is BRO minus because it lost its H plus. So I'm going to make my arrow. HBRO is our acid, which makes BRO minus the conjugate base. So when it comes to the conjugates and the pairs, I always know that they're opposite. Like an acid turns into a conjugate base. That's just a helpful tip for you. But I can also logic through this, right? Because if this reaction runs in reverse, the BRO minus becomes HBRO. It gains a hydrogen, and the definition of a hydrogen of a base is a hydrogen ion acceptor, something that gains a hydrogen. Okay. So that tells us that the water should be acting like a base, but let's investigate. So water, H2O, turns into H3O plus. How did it get an extra hydrogen and become positive? It gained the hydrogen ion from the acid. So if it accepts a hydrogen ion, water in this case is acting like a base. And the H3O plus is called hydronium. I'm going to do a whole lesson on water later. But this is where that H3O plus hydronium comes from. So in the reverse, it loses it. So it acts like the acid in the reverse, but we're going to call it the conjugate acid. And again, if you remember, the conjugate version is always just the opposite of what was on the reactant side.